right. So before we begin Java and object-oriented program, right? Let's do a little bit of basics of computer. Okay. Now you do hear about things all the time, right? So you have hard disk, and then you have RAM, and you have CPU, right? Okay, so does anyone know what is this hard disk? What's this hard disk?
Is it a monitor?
Storage device.
It's a storage device. So you see, when you see these drives, C drive, D drive, right? Where you have all your files. You have your songs, videos, your files, your programs, right? So this is where you store all of the files. Okay, all the installation, text file, or any installation that you do, right? The Chrome installation, Spring Tool Suite, all those files are stored somewhere on the system. That is the hard disk. Okay, this is a long-term memory. Okay, so everyone follows what's a hard disk drive?
Yes.
Okay, now this is called long-term for a reason. Okay, now when you restart your machine, right, you shut down, you pull the plug, okay, or you reboot your laptop, do you lose all the files in the C drive, D drive that you have, or will they be still there if you restart your machine?
Still there.
Yeah, it's still there.
Still there, right? And hence the term long-term memory. Okay, this is a long-term or persistent storage. Persistent meaning it is permanent. Okay, it is persistent, it is permanent, it is a long-term memory. You won't lose this data even if you reboot. Okay, now RAM on the other hand is a short-term memory. Okay, meaning whatever information you have in this memory storage, it will be lost. It will be on a short-term basis only while you're using the software. Okay, so let's see how this works with an example. Now, I don't know how many of you own houses. Do you guys have anything like a closet room, garage, or a storage space?
Yes.
Right. Now, let's say you have a backyard, okay, and you want to clean up your lawn, mow your lawn, do pest control, whatever, right? So you have these things, okay? You have things like you need hand gloves, okay? You need your mask, okay? And you need your pest fertilizer spray, whatever that is, right? And you need lawnmower. Now, all these things you usually keep in the storage space, right? Or do you always carry that with you?
Keep it there.
Keep it there, right? Now, let's say once in a month you try to clean up your backyard, okay? Now, do you bring these instruments outside the storage and start using it where you want?
Yes.
Right? So that's what we do. Now this is a long-term location, long-term storage space. Okay, this is where we keep all our things permanently. But only when we want to use this, like it is the day of the month when you are supposed to do your lawn mowing or cleaning, pest control, whatever, right? That's the time when you move the things from your storage to your backyard and then start doing your thing, isn't it?
Yeah.
That's how you need to understand, you need to remember the hard disk and the RAM. RAM is a space, okay? It's a workspace. This is where you do the actual work. And what is hard disk? It's a storage space.
Storage.
Okay, just like the example, this is a place like closet, okay, or storage or garage, wherever you keep your things. You know, you keep your umbrella, you keep your shoes, and you keep your lawn mowing equipments. All those things you keep in the garage or the storage room, and you only take them out when you actually want to use it. Okay. Now this is the one permanent space where you keep all the time. But only when you want to mow the lawn, that's when you move these items from your storage into your backyard. Okay, even backyard is your own space, right? This is what you own. Okay, or the whole lot, your home, your backyard, your garage, living room, this is all the space that you own. But all the things, these all things are not carried in your backyard all the time. You keep them in a specific space. Okay, you keep an umbrella. Do you always carry that when you're eating, when you're sleeping, when you're, exercising? Do you always carry that with you, or you only bring that out when it's raining?
When it's needed, yeah.
Right? So that's how you need to think about this long-term memory and the short-term memory. RAM is a space, okay, which is like a workspace. This is a space which is meant for storage only. Okay, this is a permanent location for all these items. We only bring out certain items from these when we need it. For lawn cleaning, we bring out these. For pest control, we bring out these. If it is raining, I'll bring out an umbrella. So these are the permanent locations for storing. Whereas, this is the location where you bring out all these equipments only when needed. Workspace and storage space. Does that make sense?
Yes.
Now, CPU is like a brain of your system. Okay, it's like a brain processing unit. Now, if I ask you 2 plus 2, what do? You calculate what is 2 plus 2 in your mind, right? Your brain calculates that, isn't it? Similarly, this is one of the hardware that is found in your laptops or PC, desktop, whatever, right? Or even in your cell phone, okay? There you find a particular chip, a particular electronic equipment, which is called CPU, which is like the brain of your system, brain of your machine. It processes just like your mind, okay? Now, just having this space, if I say what is 1 plus 2, okay, that value 1 plus 2 goes in the workspace, okay? That value comes here. This is where you store that value 1 plus 2. But who does the actual addition of 1 plus 2? The CPU.
CPU.
The CPU.
CPU is the person who is responsible for adding these two numbers, okay? So RAM, or the short-term memory, is only meant for storing the value of whatever input you want and whatever instruction you want. You say, I have two numbers, 1 and 2, and the instruction for CPU is to add these two numbers. So what RAM has is, it has the input and the instructions. Okay, the input is 1 and 2, two numbers, and the instruction is add these two numbers. So you give the input and the instruction, and CPU will do that for you. CPU will actually add that. So this is the computation unit. It will compute, it will process, it will execute, just like your brain. Okay, so that's what CPU is. Okay, does that make sense?
Yes. Yeah.
Okay, so any laptop that you have, be it a Mac computer or a Windows based Lenovo, Dell, whatever laptops you have, right? All those laptops will have these components. It will have a long-term memory hard disk, which is like a permanent storage space, then a short-term memory, which is just like a workspace. This is where you actually do the job. Okay, this is only for storing, but when you want to do something with this information, it will be transferred to the RAM. Okay, and CPU is the person who will actually do the computation for you. Okay, so any laptop that you ever own will have these units. Doesn't matter it is a Mac or a Dell or Lenovo. All these laptops will have these units. Okay,
You said CPU do the work, right?
correct.
Okay.
CPU does the processing, the computation. Okay, RAM is meant for just holding the data that you need, okay, input and the instructions. But what to do with that instructions and on that input is decided by the CPU. Okay. All right. So this is what you have in each of the computers. Okay. Now the next question is, you always hear the term GB, right? GB and MB. Have you heard these terms?
Yeah, terabyte,
Yes.
TB.
Yes. Terabyte,
Terabyte, megabyte,
gigabyte, megabyte. You keep hearing these terms.
terabyte.
Every time you come across something called memory, okay, short-term memory or long-term memory, hard disk, RAM, register, whenever you hear the term memory, you keep hearing this TB, GB, MB. Okay, so let's see what this is. Okay, now T stands for tera, B for byte, BYTE. This is gigabyte, this is megabyte. Okay, and what comes beneath this?
KB, kilobyte.
Very good. And below KB,
Uh,
just byte.
right.
Okay, what comes below byte?
Maybe nanobyte. I don't know.
There is a lowercase b as well. Does anyone know what's the lowercase b?
Is it a
Bit.
beat?
Bits.
Very good. This is bit, this is byte, this is kilobyte, megabyte, gigabyte. Okay, and this keeps going. There is petabyte and all that. Okay, PB and things like that. Okay, petabyte is like 1000 terabyte and so on. Okay, now let's see what these things mean. Okay, bit. So one bit is 1 or 0. Okay, so have you heard this term? Everything related to machine is 1 and 0,
Yes. Abacus.
right? So binary. So we call this as binary systems. Okay. Now this is what happens, right? In your computer, you have several different files, right? You have a video file, an audio file, text file. You have some Google Chrome installed, Spring Tool Suite installed, right? Now, how does all that information get stored in here
Binary.
in binary? Remember one thing, these computers can only understand 1 and 0. They can only understand binary system 1 and 0. So every information that you ever come up with, okay, well, you might be writing an email, you might be listening to music, you might be downloading a video, all that information will finally go here as ones and zeros. Okay, so let's take an example and see how that happens. One bit is 1 or 0, right? Okay, so we have this thing. So one bit is 1 or 0. A byte consists of 8 bits. 8 times into bit is equal to,
Byte.
yes,
1 byte.
okay, so this has some Excel. Okay, so this is a 8 times into 1 bit equals to 1 byte. Now kilobyte is 1024 times
1020.
1 byte. Okay, that is kilobyte. Now 1024 times 1 kilobyte equals 1 megabyte. One thousand 24 times 1 megabyte equals a gigabyte, and gigabyte 1024 times equals 1 terabyte. Okay, so that's the usual process. Okay, everything in binary is multiples of 1024. Okay, even though kilo stands for 1000, isn't it? Right, 1
Yes.
kilo stands
Yes.
for 1000.
Yeah.
But in
1000.
computer term, they don't really consider kilo as 1000. They consider 1024 as 1000. Okay, so it might be confusing. When you see kilobyte, you might feel this means 1000 byte, but no, it means 1024 bytes. Okay, so that's what this size is. Okay, so this much data you can have on your machine. Okay, so this GB is like a billion bytes, right? A billion. So 1000 billion bytes is what your machine can store if you have 1 terabyte. 1000 billion bytes, that much information can be stored. So do you guys understand the terms? GB, kilobyte, and all this?
Yes.
Yes.
Now let's go back to this thing, right? Like I said, everything in the end is stored as ones and zeros in the memory. You might have an email, okay? You might have stored a telephone number, okay? You might have audio, a music, some music file, or you might have video files. You might have installed YouTube, okay? Whatever you have, all this information that you have, that you see here, right? All this thing, they are all stored as ones and zeros in the end here, okay? So let's start with a simple example. Let's say you want to store the number 1000 in your computer. How does this number 1000 get stored if everything is 1010, right? Let's try that. Let me pick an odd number, 23. Okay, I want to store the number 23 in my computer. So on the top here, I will say 23 like this. Okay, so let's say I save number 23 in a file. Okay, now this file, which has the number 23, right? How does this file get stored? Okay, how does the number 23 get stored? Okay, on the surface, it might look like a very user-friendly, humans can read this, right? But that's not what happens internally. Okay, so let's see what happens with the number 23. Since everything is a bit, right? One bit is either value 1 or 0. Okay, what's a byte? It is 8 bits. Okay, 8 bits. So you have about 8 fields 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is 1 byte. 1 byte equals to how many bits?
8 bits.
8 bits. Okay. Now in every bit, what is the value you can store? You can store either 1 or 0.
Or 0.
0.
1 or 0. 1 or 0. 1 or 0. So if I want to store 23 in my computer, I say computer because laptop is not the only place where you can store information. It can be your cell phone. Even that's a computer, right? Even that has memory, GB and all that. Okay, your laptop, your tablet, your desktop, PC, everything has memory. So I'll use the term computer. Okay. So any computer that wants to store the number 23, how can it be stored in ones and zeros? That's the question, right? So here is what you do. 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, 6, 7.
Okay, where'd you got the 2 from?
Sorry?
Where you got the 2 from? Like you give 2 to the power 0. How you got the 2? Like I'm confused in the top line. Yeah, 2 to the power 0. Where you just guessing, or you just like where 2 came from?
This is a binary system, so everything will be 2 to the power.
Mm-hmm. Okay,
Binary,
it is just okay. It's been
yes,
okay,
binary meaning
given.
here you can have only 2 values, right? Either 1 or 0, right? Bit meaning you can have only 1 or 0, and hence it is always 2 to the power, 2 to the power, 2 to the power.
Oh, because of 0 and 1. Okay, okay, that makes sense. Thank you.
Now, does anyone know what's the value of 2 to the power 0?
0.
0.
Is it 0? It's 1.
It's 1, 1.
2 to the power 1,
2,
2.
2,
then
4,
4,
6.
8,
Oh,
8,
8, sorry.
64.
9, 16.
see, 2 to the power 1 meaning, 2 to the power 2 meaning 2 multiplied by 2.
Yeah.
2 to the power 3 meaning 2 multiplied by 2 multiplied by 2.
By 2, yeah.
Okay. This 2 times 2 times 2 times 2.
Times 2.
Okay, that's what you need to do.
34.
Okay.
Yeah, 2 times 5 is 34.
So this will be 32,
32. I'm saying 34, 32, 64,
120.
and then 1.
Okay. Now let's see how we can get the value 23 with this thing. Okay. Now pick up any combination of these numbers and add them up to 23. Pick any combinations, okay? Like something like 16 plus 8, 24. No, doesn't help with
8 plus 4 plus 2
Plus,
plus
No, 16, 4, 2, 1.
very
yeah,
good.
16, 4.
So these are the bits that has to be turned on. 1, 1, 1, and 1. These are the bits that needs to be turned on. So when you see 1, take 16. 1, 4. 16 plus 4, 20. 1, 20 plus 2, 22. 1, 22 plus 1, 23. So how do you store 23 in the computer? Like this. So this is how 23 gets stored in the PC. Does that make sense?
Yes.
Everything else is
Yeah.
going to go 0. Yeah.
Now how do you store the number 10? Give me the exact number.
8 plus 2.
8 plus 2.
So that would be
0, 0,
0.
0,
0,
0, 0, 1,
1,
1,
0,
0,
1,
0, 1, 0.
0.
0.
Exactly. This is how the number 10 is stored in the memory. Okay. All right, just give me a minute. Right. So you get the idea, right? How computer stores every single information that you have, that you see here on the drive in the memory. Okay, it might sound like the number 23 here for you, but underneath, when it stores it, it will store it as 10011. Okay, everything is ones and zeros, even letters, you know. So for the letter A, the number is 65. For the letter B, the number is 66. Okay, so this, what they do is, now if you want to store, let's say, if you want to store the name bad, it will be stored as 3 set of 8 bits. Okay, one for storing the number 66. For B, for A, you need another 8 bits to store the number 65. And for D, you need another 8 bits to store the number 67. Okay, if you're storing the name bad, it will get stored as 65, 66, 68. Okay, so B is 65, 66, right? So what's the number that gives you 66?
0, 1, 0, 0,
1,
64 plus 4.
and this one, right?
64 plus 1, yeah.
Okay, so this is how you represent the letter B, which is represented as number 66. And for 65, it will be more like this one.
64 plus
Yeah, 1 at the
1.
end.
64 plus the first bit,
1.
whose value is 1. Okay, so this is how everything gets stored. Even your audio files, your video files, the Spring Tools suite that you installed, the JDK that you installed, everything underneath goes as ones and zeros. Okay, so let's not, this is the basics. Okay, this is how everything gets stored. So are you clear on what is a binary system? What is that GB and terabyte and megabyte and everything?
Yes.
Yes.
All right. Now here is the question. If your laptop is only designed to understand ones and zeros, how are you able to, communicate with that? If your laptop only knows what, if a computer knows only 1 and 0, how are you able to operate your cell phones, your laptops, your tablets?
Processing.
Processing what? See, this only understands ones and zeros.
Converting them into binary form.
Anyone?
Updating.
Yes, operating system. That's what the operating system's job is. Okay, on top of this, you have a software. Now this is all hardware. Okay, so you have a physical laptop which has a physical chip inside it, right? It has a physical chip, it has a physical hard drive, it has a physical RAM. You can see all that electronic circuitry in your laptop, don't you? These are all hardware.
Yes.
Okay, hardware is something which is materialistic thing, which you can touch, which you can see. That's what we call hardware.
Yes.
Okay, Now, operating system is the one software that runs on top of this layer, which is making somehow this whole complex ones and zeros readable. The operating system is helping you out in reading this thing, The whole reason you're able to read this in human readable format is because of operating system. If there was no operating system, everything would look like this. Now imagine if there was no operating system and you want to read the letter BAD. Do you have the patience to keep converting every character by character here and come to a decision that, okay, the first letter is B, the second letter is A? Do you have that patience to do? Is that humanly
That's not
possible?
possible. Not possible.
No.
It's not possible. So operating system is what comes next in your computer layer. These are all hard terms. These can only understand ones and zeros. But operating system makes it somehow bearable. Now, operating systems are an interface. Interface to what? Interface to your hardware. Interface to your computer. Okay. So do you understand what does the term interface mean? Interface is when you interact with someone, isn't it? So when you want to read an audio file, when you want to read your telephone number, when you want to read a text message, operating system can interface with this underlying ones and zeros binary system. That's what operating system is. So what we call it is, it's a graphical user interface for your machines. A graphical user interface. Isn't this graphical? You have a nice window, you can see, you can type, you can move your mouse. That's what we call graphical. Graphical is more you can interact with. Okay. Without that, everything is ones and zeros, isn't it? If there was no OS, all I can see on this screen is a black screen with numbers, ones and zeros. That's all I would see without the operating system. Because we have operating system, we have this nice graphical interface where we can interact with more complex data that is like this, ones and zeros. So do you know why we need an operating system now?
Yeah, it needs to communicate with the system and user.
It translates to your underlying machine language. Okay, machine can only understand ones and zeros. This is making easier for you to access your drives. You can just go here and click here and click here, and then you can open this and see your file. You can read your file. All this activity, all this action that you see is possible because of your operating system. Okay. Now, what are the type of operating systems that you find? This is a software.
Windows, Linux.
You have Windows, you have Unix, and you have Mac. Okay. These operating systems are basically interacting with your underlying hardware. Okay. This hardware, the memory, the CPU, these are all interacted by your operating system, and they come in different varieties. You have Windows. This is one software that can allow you to do the same thing. Think about this like if you want to go on a trip from New York to Las Vegas, right? Is there some rule that you have to always go in a Nissan car? Or you can use any type of vehicle?
Any type.
Any type of vehicle, right? So
Yep.
if your underlying machine is this configuration, you have some hard drive, RAM, and CPU, you can use any type of driver to access this thing. It could be a Windows operating system or Mac or Unix. They are just different flavors. That's all. Okay, just like the end goal is to access your computer. How you access that is based on what operating system sits on top of it. Is it a Windows operating system or Unix or Mac? That's all. Okay, these are different companies that provide you a way to access these hardwares. Windows is provided by the company Microsoft, right? Mac is provided by the company Apple. It's like the
Yes,
same
yeah.
example I gave you. Nissan, okay, a Mustang car is owned by the Ford company. You can use a Mustang or you can use a Hummer. You can use anything you want to go from point A to point B. That's what we want, right? We want to go to Vegas. That's the end goal. How you go there is based on what type of vehicle you choose. There is no restrictions on what you choose. Similarly, if you have a laptop, you can install any operating system on that. You can install Unix or Windows or Mac. Anything is fine. It is just a means. It is a means to access your hardware, to access your computer. That's all. When you drive a Hummer and the Ford Mustang, isn't the look and feel different? How you
Yeah,
drive,
exactly.
what are the controls in a Mustang car versus a Hummer versus a Nissan car? The look and feel, how it looks, how are the driving controls? Okay, what are the options inside the car? Aren't they all different?
Yes, they're all different.
They're different, but they let you achieve the final goal, which is going from point A to point B, isn't it?
Yeah.
Mm-hmm.
Similarly, Windows and Mac, they all allow you to access your underlying binary, complex 1-0, CPU, RAM, everything. Okay, but isn't the look and feel different? How does my
Yes.
operating system look? And have you ever noticed how the Mac screen looks like?
Yeah.
Aren't they
Yes.
two different versions? The way it looks,
Yeah, that looks different.
they look different. The Mac has a different look and feel. Okay, you might not see an option like this. This, if you want to see what is in D drive, it might be totally different when it comes to Linux or Mac. If you want to open this text file, it will be totally different in Mac or Unix or Windows. But the end goal is the same, to read this file. I want to read this file. End goal is same. I want to go from point A to point B. The personal experience is different. Okay, you might feel little heavy on Hummer. Okay, you might feel a little faster speed and all that in Mustang. In Lexus, you might have a luxury feel. Your experience, your personal experience while you drive the different car is different, but they all are meant to do the same thing, which is going from point A to point B. That's the end goal, but your experience is different. The same applies here. If you have a Windows machine, how I access these is totally different. If I want to access my video file, I will go to my computers, click on my drive, and I open my music file. Experience is different, but in the end, I'm listening to music. In the Mac, it might be totally different. This screen might be totally different. In Unix, it will be totally different. That's the only thing. Your experience is different, but the end goal is the same. Access whatever is here, whatever ones and zeros you see underneath, I want to access that thing. That's the only purpose. So you guys understand what is the operating system, what's the difference in Windows and Mac and all that?
Yes.
Okay. Now, on top of operating system, we start installing different stuffs. Okay, we install Okay, we install Chrome. Okay, we install Spring Tool Suite. Okay, you install YouTube, Java, Netflix. Okay, you install all this software on top of operating system. Okay, or you install Notepad. Okay, so these are the software that comes next. You install this software on top of this. Now every software has a specific reason, right? What does the Notepad do?
We can write down, keep a note.
You can edit file, you can delete. Okay, you can edit, you can delete, you can save. That's the purpose of Notepad, right?
Yeah.
What's the purpose of Netflix?
Watch movies.
Entertainment.
Everyone answers what's a Netflix. See? What do you use for the Chrome for?
Browsing.
Browsing
Browser.
internet. So every software that you have here has a specific purpose and they are installed on top of your operating system. And finally, who do we see here? The user. Okay, now the user will launch YouTube and start watching videos. Launch Spring Tool Suite, start working on Java programming. Open Chrome and start browsing internet. Notepad, start writing, editing some text files. That's what you do. So this is the entire picture of what you guys have been doing until now with your laptop. Okay, you can install as many softwares as you want: Facebook, YouTube, Netflix. Okay, a banking app. All these are installed here. So where do you guys come into picture? Which layer? This layer, or
User
this layer?
layer.
User.
The user.
User are the customers, are your customers. Until now, you guys have been the users of the computer system.
Second layer.
Users of YouTube. You have been users until now. Remember, now you guys are not the users. You are the providers. You are providing these softwares for other people to use.
Developers, yeah.
This is where we belong. Apps. We will produce applications, softwares. Thankfully, we don't have to deal with this complex operating system layer. We don't have to deal with ones and zeros, isn't it? So that's the good news. You guys belong at this layer. You will design softwares for Netflix, YouTube, Spring, Chrome, softwares like this, where other people can use your programs. Your program will sit here on top of an operating system.
So who will be looking for the compatibility and accessibility of the software we develop? Who will be playing the role for that part?
Compatibility as in?
Like the software we develop in each person of the like browsing or operating system, it will be compatible. Or if the browse, like if I develop any of the program or any application, then in which I mean, like in which operating system it will be compatible to? Is that for iOS or Android or Windows?
Very good, very good. That was my next point actually. So you guys understand, right? What you guys have been doing so far.
Yeah.
Okay.
Yeah.
Yes.
This applies to everything. This applies to even cell phones. So what's the operating system in cell phones?
iOS or Android.
iOS or Android.
Very good. That's the operating system. And on top of this operating system, you have different apps. Okay, you installed Netflix, Facebook, banking apps, financing apps. You installed all those apps on top of these operating systems. and you so far as a user has been using these all apps. Okay, now let's get back to your question now. The one beauty of Java software, it is platform independent. Okay, so let's see why. Now, Java comes with two flavors, right? JDK and JRE. Okay, so let's see why we needed these two things. Okay, now every time you write a program, there is something called compiler which steps in. Okay, so let's see what that is. Now, does this program look like a binary, ones and zeros? Does this look like a binary?
No,
No,
no.
it's a human readable file format, text file, right? So we call that as a source code. Okay, source code is a human readable format. Okay, this is human readable text format. Okay, as you see, you can read this. It's a plain and simple English. Okay, you can read this text file, human readable format. We call them as source code. Okay, these files usually have the extension .java. Okay, if you look carefully, what are every single file that you create ends with? What is the extension? .java. Okay, so .java file is a text file.
Java extension.
Okay,
Yeah, text.
so text file which we call as source code. Okay, now when you install JDK, it comes with two things: compiler and JRE both. Okay, JRE of course has just JRE. Okay, let's see what is this additional thing we required as part of a programmer, as part of JDK. Being a programmer, you need one more thing other than JRE, which is compiler. You can only find this in JDK installation, not in JRE. Okay, the job of compiler is to convert this into something called intermediate binary code. Now, what kind of data we have here? Binary. Everything is 1 and 0, right?
Mm-hmm.
If everything is 1 and 0, we call this as binary data. Everything finally goes down as binary. So let's see what is intermediate binary means. Okay. Now these files end with the extension dot class. Okay. Now, do you see any file that has the extension dot class? Anything?
No.
You don't. Okay. So let's see. Where is this workspace? Right click, properties. This is where the workspace is. In your case, if you guys remember, you created the workspace in C, Java training, Java workspace, isn't it?
Mm-hmm.
That's where we'll go. Now here you see only one folder, SRC, right? What's the other folder you see here?
Bin and class path and project.
And what is that abbreviation for?
Oh, binary?
Yes. Okay. SRC stands for
Source
source.
code. Ah, source code.
Yes. That's why it is called
Oh.
SRC. Source code. SRC is the abbreviation for source.
Source code. Oh.
And bin is the abbreviation for binary. Okay. Now, if you want to see this side by side, I can show you. Every file that has .java extension, you will see an equivalent .class file as well. Okay, so I'm in the same folder. Okay, so I'm in the same folder. Here I'll open source, and here I'll open bin. Okay, now let's look at this. We have accountant Java, right? What do you have here?
Count class.
Accountant class.
Dot class, yeah.
.class. You have address.java here. What do you have here?
Others
Dot
class.
class, yeah.
And this is
Was
class.
8.
That goes for everything. Array test.java, array test.class. Bank.java, bank.class. Bank account, bank account.class. This is in the bin directory, and this is in the source directory. So for every class, you need a .class file.
Source code.
Yeah. So this is the source code, and this is the intermediate binary code. Remember,
Binary.
this is the source code. This is the intermediate binary code. And how do you go from source code to intermediate binary code?
To class.
Through the compiler.
Compiler.
Okay. So when you write the program, compiler is the one component. Okay. Compiler is a piece of your JDK software. Okay. When you install, your Eclipse is silently converting your .java into a .class file. Let me show you that. Okay. So here in the bin folder, okay, do you see any program called ABC? It starts with ACC. Do you see any program called ABC here? Now let me create a class called ABC and let's see what happens. I created a program. What do you see here?
Class is created for that.
A class is created for that. Okay. So compiler is a program that will compile or convert this human readable format into a intermediate binary format. Okay. I'll explain it in short, but just remember, every time you every time you write a code, this file will automatically convert into dot class. Okay, so when the time is 7:20, right? I made some changes. I will save it. What's the time now?
7:21.
21 update. Time is updated.
So it is happening in live. Okay, this is happening live. Every time you make some changes, okay, and you save it. Okay, every time you make a change and you save it, and you will see a new updated file right here. This is happening while you're writing the code in the background. It's happening without you knowing it. Okay, because what Spring Tool Suite does is Spring Tool Suite will use this compiler to convert your human file format into an intermediate binary format. Okay, 722. 721. I save it. 722. So every time you make some changes, someone is converting your file into dot class. Okay. Now let's see. I told you, right? This is an intermediate binary code. Binary means ones and zeros. Okay. .java you can read. Now if I open this in a notepad, will you be able to read the content of this?
No.
Can you make any sense out of this?
No,
No.
it's not readable.
That's a binary code. Okay? You cannot read binary file in a text editor. This is a text editor. You can only read Java files, which is a text file. Okay, if I want to open the source code, see, this is the Java file, right? abc.java file. If I open this, yes, I can perfectly read this. It's a text file. Okay, just like how you can read here, you can open that file in a text editor, but you cannot read anything in a binary file. This basically doesn't make sense. ACK, SOH, nothing makes sense. That's the difference between binary and text file. Binary and the source file. This is the source code. You can always read the source code in a text editor, but you cannot read a binary file. This is supposed to be for your machine to understand. This is not human. This is not for humans. This is for machines. Binary is only intended for machines to understand, not for you. Right? So you guys understand what is the class file and Java file?
Mm-hmm.
Yes.
Let's see what is this term intermediate. Okay. Now after this we have something called JVM. Okay. JVM is part of this component, JRE. Okay. So JDK has compiler and JRE. JRE has only JRE. Okay. So JVM is one component of JRE. Let's see what is the role of this guy. Okay, so this is what you got as part of the JDK installation. When you did JDK installation, you got the compiler as well as JVM. This is what you installed actually. Okay, JDK has compiler and JRE both. Okay, so JVM is part of your JRE. Okay, so if you install JRE, what do you get?
JVM,
You just get this part. You do not get this part.
the compiler.
Okay. All right. So this is what we call an intermediate binary code. Now, what do you have here? What kind of code do you have here?
Binary.
Just binary. Okay. And this is an intermediate binary code. Okay. Now coming to the first question that I got here, right? How do we write a program which is compatible to Windows or Mac or Android and things like that, right? This is what makes it possible. This layer makes your program platform independent, meaning if you write your program on this operating system, what is my operating system?
Windows.
Lenovo.
Windows. If I write a program in Windows operating system, I can run this program. Anybody can run this program, no matter they have Unix or Windows or Mac. So when I write a program, it is universal. Anyone can use this program, no matter what operating system you have. And the reason all that thing is possible is because of JVM. If you remember, this is an intermediate binary code. This JVM will convert your intermediate binary code into
Binary code.
binary code. This is the guy who is responsible for converting this intermediate binary code into full-blown binary code. Okay. So when I write the program, right? So when I write this Java program, you see that I have a class file here, right? If I give this class file to a person who has Unix operating system, they are still fine. They can run it. If I give the same file to a Mac operating system, that user can also run my program without any problem. Okay, so let's see what the interpreter did here. Okay, interpreter job is to convert intermediate binary into binary. Okay, now when you guys were installing this JDK, JRE, all that, did they ask you specifically what operating system you have?
Yes.
Yeah.
Yes.
And that's what the JVM does. If you choose Windows 64 JDK or Windows 64 JRE, what you get here is Windows JVM. Okay, what you get is Windows JVM. If you choose a Mac JDK installation, what you get here is a Mac JVM. Compiler remains same throughout. Everyone gets the same compiler, no matter you belong to Windows operating system or Mac or Unix. Everyone will get the same compiler. Okay, think about this like a translator. Okay, now here this is my message, hello. Okay, here we have some person who can understand Mandarin, okay? And some person who understand Hindi. Okay, and name any other language, French maybe. Okay, French and Spanish. If I want to say hello to these people, who do I need? Who do we need here?
Interpreter.
Compiler.
Translator.
We need a person who can translate my English to Mandarin, right?
Yeah.
If I want to say hello to this person, there is a Mandarin translator. If I want to say hello to a French person, there is a French translator who can convert my message into French language. Now, do you see the resemblance to this and JVM?
Yes.
Okay,
Yes.
so the same thing happens. The same thing happens with respect to the Java settings. Okay, here I have my intermediate binary code. Okay, which is, what is the file extension? For intermediate binary code,
JVM.
what is the file extension? What is the file extension for source code?
Class.
Dot class.
Yes,
Dot class.
the .class file. So here we have Windows JVM, and underneath I have the operating system Windows. Here I have a Mac JVM. Underneath we have the operating system Mac.
Right.
Here I have the Unix operating system and the Unix JVM. Okay, so if I give this class file to a person who has Windows operating system, what is the JDK installation gave him?
Yes, Windows JVM. So
Windows JVM.
that can convert.
If you run Mac, remember these are the different users. Okay, these are the different customers. Okay, now all the customers who need to run Java program, they have JRE. Don't you you remember that, right?
Mm-hmm.
The purpose of JRE is for the customers. These are my customers. Okay, so these are my customers. My customers can have a Windows operating system or a Mac operating system or a Unix. They can have any laptop, any platform, any operating system. Doesn't matter. What they need to have is a specific JRE. Okay, so if you recall, we had Windows JRE, Mac JRE, Unix JRE. So when they install Windows JRE, they get Windows JVM. When they install a Mac JRE, they get Mac JVM. Okay. So when I write the code, I can
have it.
right? So all the customers have JRE installed. We as a developer have JDK. When we have JDK, we get one additional thing other than JVM, which is
Compiler.
compiler. So we get one more thing other than JVM, compiler. So when we write the program, compiler converts that into intermediate binary code. You can give this file to a person who has Windows JVM or a Mac JVM or a Unix JVM. And that JVM knows how to talk to Windows operating system or a Mac operating system or a Unix operating system. Remember the layers, okay? Immediately after JVM, who comes next? The operating system. So if you have a Mac operating system, you need Mac JVM. Unix operating system, you need Unix JVM, and so on. So based on what operating system you have, you will have one layer sitting right close to operating system who can talk to underlying operating system, just like a translator. Okay, my message, English message, will be translated to any language provided I have a translator. Similarly, my program can be used by any platform operating system provided they have what they should have.
Yeah.
They need a JVM or JRE, whatever. Okay, so remember, you might see this term 2 times, JVM, JRE, but JVM is just a subset. Okay, it is a part of JRE. Okay, JRE has lot many other things. Okay, JRE has lot many other files that you get. JVM is just a piece of JRE. Okay, just remember that if you're confused about both the terms. It's only a subset of JRE. Okay, so my program can be used by any person, Windows or Mac or Unix, provided they have some translator or interpreter. Okay, here we say interpreter. So JVM is an interpreter. It can interpret your language, your intermediate language, into underlying operating system. Okay, so now you see your Java programs are platform independent. This is one of the strongest feature in the Java programming. Okay, you don't have to write a code in all the languages, all the operating system. Okay, if you have like 10 different customers with 10 different operating system, you don't need to write 10 different programs. You can write only one, and when they install the JRE, they can use it without any problem. Okay, all right, so any questions?
No.
All right.